Hello and welcome to an episode of One-on-One with Mersen. My name is Kian Sanjari, and today I'm joined by Dr. Philippe Roussel, VP of Strategic Marketing at Mersen, to discuss the usage of silicon carbide power modules in industrial applications and some of the challenges associated with this new technology. We will then also review Mersen solutions to address these application challenges. Hello, Dr. Roussel. Thank you for joining us today.
Hello, Kian. I'm glad being with you here today.
Great. Our customers in the power conversion design market are constantly looking to increase the efficiency of their inverter designs and at the same time trying to reduce the footprint of their systems. We've seen in the past several years a surge in using silicon carbide, also known as SiC, based power modules in a variety of power conversion applications and markets, ranging from industrial inverters to e-mobility. I think it would be safe to say that SiC has now entered in its industrial phase. Why do you think our customers are now considering using SiC modules? What are the advantages of this technology?
Yeah, that's absolutely true. So after almost 30 years of development, the silicon carbide is now on the marketplace. And I think it's a fantastic news for power electronics conversion business. And silicon carbide is really a fantastic technology. It allows really to increase the efficiency of power conversion while decreasing and shrinking size and weight, which is a kind of holy grail for all engineers in power conversion. So now it's ready. We have both diodes and transistors, so we are able to build power modules, and with power modules, we are able to power the systems, and the systems are now on the marketplace, and it's a big step, I think, for power electronics.
Great, good to hear that. Now, taking into considerations the advantages that you just mentioned of using SiC modules, which applications do you think are the most promising ones to adopt the SiC technology, and how is Mersen involved in these industries?
Yeah, indeed. Historically, it has started with PFCs, the power factor correctors, for one very easy reason. We only had at that time diodes available, Schottky diodes. And so with Schottky diodes, we were really able to increase efficiency of PFC by a factor 20, 30% more efficient. And it has started with very high-end application in medical, in military or defense or even telecommunication application. Then came the transistor. So the transistor is on the market roughly 10 years, 12 years ago now, and it allowed to target new markets. The first one to be really addressed with silicon carbide was PV inverters, for which you can really gain a lot on the efficiency. And I remember the first advertisement on PV inverters with SiC were claiming 99% efficiency. And that was true, 99% efficiency. That was totally unbelievable in this power electronics conversion world. And it happened. It happened for real. And then some new application came along on board with silicon carbide, and it started with trains as well, traction, railways, and there are real trains and metros currently running silicon carbide on a daily basis. There is one famous in Tokyo. Every day of probably hundreds of times back and forth, the metro is running silicon carbide with absolutely no issue. So it's really growing fast. The next big thing that we see with silicon carbide will definitely be EV, electric vehicle, that will benefit from this increase in efficiency and reduction in size and weight. And again, for this application, it's obvious that silicon carbide can bring a lot. So Mersen, we are active all over the value chain. And as you know, the company is split between one very material-oriented segment, which delivers some graphite insulation components for sublimation reactors insulation. Those reactors are made to grow the silicon carbide goods. We are also active a lot on wafer carriers. It's made of graphite covered and coated with silicon carbide, used in the MOCVD epitaxy processes. So this is for the material aspect of it. In power electronics, we at Mersen, we are offering basically 4 product lines. Busbar, cooling, with both technology, liquid and air cooling, capacitors, and fuses for semiconductor protection. That makes the full offer of silicon carbide. So again, Mersen is very active all over SiC value chain.
Yeah, from what I hear, I think that Mersen is very well positioned to serve that market and be very active in it. We also talked about the efficiency of SiC modules, and from what I know is that compared to other older silicon-based devices, you get a much more higher switching frequency capability with silicon carbide. It can go all the way to 20 kilohertz. I'm sure that we all kind of know that, the downfall with this type of high frequency switching is heat that is generated. And
Yeah.
and compared to older technologies like IGBTs that were around, how does inherent attributes of SiC impact electronics design? Things like extra heat generated by this high frequency.
Yeah, you're absolutely right. And I can say it's not only 20 kilohertz, sometimes it's even 100 kilohertz that we are facing at our customer place. So yeah, things are really moving fast and up in frequency. Just to remind the audience that a typical silicon IGBT is running 3, 4, maybe 5 kilohertz at maximum, knowing that IGBT is probably what we do the best in silicon technology. With silicon carbide, 20 kilohertz is kind of nothing. 100 kilohertz can be easily addressed. So now it's a question of trade-off. I mean, for sure, if you want to decrease the size and the weight of your system, better use a high switching frequency because it will elegantly help decreasing the size and weight of your passives component. And typically, we are here talking about capacitors and inductors. So the higher the frequency, the lower the size, and the smaller, the size of those devices. So it means that if your application is dealing only with size and weight, better use a high frequency. Now, if you are looking for rather efficiency, higher efficiency, there's probably a trade-off. Because for sure, the higher the switching frequency, the higher the losses, because each and every time you switch on and off and on, there is a small amount of energy that is lost, and this creates some heat to be evacuated, and this virtually decreases the efficiency of your system. So there is a trade-off. Again, if you want only size and weight, it's high frequency. If you're looking for a rather efficiency, it's probably something in between. But in any case, it will bring a lot more than silicon only.
Now, let's take a moment here and go over a topic of thermal management. You mentioned that one of the offerings that Mersen has is basically cooling solutions and so forth. So we know that thermal management of SiC is a tough challenge. How can we efficiently cool SiC modules?
That's a pretty good question in the sense that silicon carbide is all about power density increase. So in other words, you have much more calories on a given small surface to be extracted. So it causes some trouble. It's a fact. It's not easy to cool down SiC because we have so many calories to be evacuated. So here we have developed really two kinds of technology. One is air-based and the other one is liquid-based. So for the air-based, it's very difficult to efficiently cool down SiC using a simple, basic extruded heatsink. The reason is simple. The calories cannot spread over the base plate enough to be extracted from the fins. So we have to help really the energy to run through the base plate. And to do so, at Mersen, we have developed nice technology dealing with embedded heat pipe. The heat pipe is I don't want to enter the detail today, but heat pipe helps really taking and capturing the energy, the calories here and transporting there. So it helps with spreading the calories over the base plate, and using it and embedding those heat pipe inside the base plate, we can easily demonstrate that we increase by 30%, or let's say we decrease by 30%, should I say, the temperature rise just underneath the module. So rather than heating with a lot of hot spots, we can really decrease it, and we can show that for only probably 20-25% increase on the cost, we can really get more than 30% efficiency gain compared to a very basic heatsink. So this is for the air cooling. For liquid cooling, Mersen has recently patented Isomax. So Isomax, that's really the ultimate liquid cooling solution for SiC modules. So long story short, it's a very elegant design. You see on the slide, it's a so-called wavy spiral way of transporting the liquid underneath the module, and that allows, as an added value, to have almost no temperature difference from module to module, so very nice homogeneity. And on top of that is almost no temperature difference from chip to chip inside the module. So altogether, in addition to the better thermal performance and even lower pressure drop, this homogeneity allows our customer to get the module even closer one to the other, so again, to reduce and shrink the overall size of the cooling. So that's really a nice technology that we are now proposing to the marketplace.
That's great. That really gives the customers a good range of, more simpler air-cooled to all more of a complex system of liquid cooling for the application that they're working on. Moving away now from thermal management, let's just focus for a second also on the high switching frequencies and more on the connectivity and inductance of the systems. What are the implications of having a device that generates such a high frequency within a inverter component design?
Yes, it's an important point. Indeed, we are facing two challenges when it comes to the connection, the connectors. Indeed, we have the high frequency. So if you don't manage properly your high frequency frequency, the problem is that you are going to turn every kind of connectors into a kind of antenna, generating a lot of noises and parasitics in your system. So to do so, better use the laminated busbar technology. However, to use a laminated busbar technology in such a high temperature environment, we had to develop some technology in order to withstand such high temperature range. So typically, so far, we are ready and we put on the market 3 ranges of laminated busbar. One is dealing up to 105 degrees C, the other one 130 degrees C, and the very latest one we just put on the marketplace is able to achieve up to 180 degrees Celsius temperature. So this technology is really perfectly fitting with the current request with silicon carbide, for which the junction temperature now can easily reach 180, 200 degrees C. So meaning at the same time we are able to control the inductance of our busbar and to really make busbar able to resist such a high temperature range.
Excellent.
So now and I would say, Kenny, if I may, that the other big things with the inductance is how to connect the components with the lower inductance as possible, the lowest as possible. So to do so, at Mersen, we have developed a very smart approach of how to connect the capacitors on a busbar, minimizing the inductance and minimizing the air gap that normally exists between conventional mounting system from the capacitor to the busbar. So if we look at the conventional design, you'll see that there's a big air gap that is totally lost. In fact, it doesn't serve the purpose. Whereas with this new technology, patented, so-called Fisher Link, which is based upon a direct laser welded connection of the capacitor to the busbar, okay, we can get up to plus 20% on the capacitance on a given volume because we just eliminate the air gap, and we can get inductance as low as 9 nanohenry. So that's really a fantastic achievement, because here we can again shrink, as you know, it's the main purpose of silicon carbide. So shrink the size, the weight of the system, reduce the inductance, and makes it much more comfortable to handle high switching frequency of silicon carbide, even in a very high temperature environment.
Great, great. So I got one more question for you is just to summarize overall, in your opinion, how does Mersen position itself in the SiC landscape today?
Yeah, good point. Indeed, it makes a couple of years that Mersen is really addressing silicon carbide related devices. So again, we are talking capacitors, busbar, high temperature, low inductance busbar. We are talking cooling, kind of cooling that can easily manage silicon carbide temperature ranges, and fuses. Mersen doesn't position itself as just, I would say, standalone component provider. We are going more, and we are going to be, let's say, more involved into the design cycle with our customer in order not to propose only components, but also solutions. So we want to be and we are now a solution provider. So the idea is how to better co-design and optimize all those four components, surrounding components together in order to offer our customer the best compromise in a very limited period of time. I mean, we want to increase the design cycle time. We want to help our customer to quickly get to the solution, optimize the solution. And this is where Mersen is really positioning himself. So the idea is really, again, the keywords, co-design and optimization. So we are virtually the partner for silicon carbide designers. So we won't supply the power modules. This is not our core business. However, we can really supply and optimize all the surrounding components.
Very informative. Thank you, Dr. Roussel, for taking the time to sit with us today. I know I learned a lot, and it is very clear that SiC technology has indeed arrived, and our customers need to consider certain key attributes of incorporating SiC into their design. Thermal management and high frequency switching of these modules are just two of the key designing considerations for an effective power conversion systems. For more information on Mersen solutions for SiC applications, please visit www.ep.mersen.com. Again, my thanks goes to Dr. Roussel for the session, and that really concludes our one-on-one with Mersen episode today. I hope to see you all in our next session. Until then, take care.